Okay, so we're going to look at the next chapter. The next chapter that we're doing is for solving equations. That's what we're going to look at in this video and I suppose the next few videos. So to start us off, we're going to do a short one on just kind of the idea of what an equation is. So what we've looked at a lot before would be called expressions. So an expression in terms of algebra is kind of just a statement of something. So it might be x plus 3, and it might be x squared plus 2 and those kind of ones that we had. Whereas an equation will have an equal sign. So it's kind of in the word, I suppose, that EQUA part. So equation and equals. So with an equation, we're going to have an answer. And that's kind of the key difference between your expressions and your equations now. So we need to just make sure that we are kind of happy with those and comfortable with answering kind of the different types of the questions, I suppose. So looking at this here. So in chapter 6, they're saying we use different symbols using such as a square, a triangle, a star to represent what we call unknowns or variables was what we call them. And we're just getting this idea that if we look at these, for example, square plus 6 equals 10, we can say, well, the square is probably 4 because 4 plus 6 equals 10. Same thing then with the triangle. If triangle multiplied by 4 is equal to 20, then the triangle is probably 5. And we can follow it through that way. So this is called an equation because it's equal to something. And when we find what we're looking for, we say that we've solved the equations. When we find the unknown, we have solved the equation. And what I'm kind of getting at here is that an equation points out an important thing about an equal sign. And an equal sign, by definition, means that one thing is identical to another thing. So if we have an equal sign, the two things on either side of the equal sign have to be the same. And that kind of comes in, I suppose, when we do our equations. But also we have to know that more generally for solving our equations. We have to know that if I'm looking at an equation, well, what I have on one side will have to be equal to whatever I have on the other side. And this idea is going to help us work out our unknown values. So for example, we can have 2 is equal to 2, but of course we can't have 4 is equal to 3 because that goes against the definition of an equal sign. So when we think about equations, we're going to think about them like a set of scales. Okay, so a set of scales or like a seesaw, so something that's kind of balanced like this. Okay, so something that's balanced here. And if we have a seesaw like this, if I put something on one side, then that side's going to go down if I put something onto it. So to balance it out, I might need to put something onto the other side. Or in the same way, if I take something off this side, then I might need to take something off the other side. We always want to keep our equations balanced like this. So we'll keep each side balanced and equal to each other. When it's given to you, the left hand side is equal to the right hand side. So what you need to do is make sure that at all times, even when you're changing something or when you're adding something in, as we will be doing, that even when we're doing that, we're not changing it in such a way that it's no longer equal. We have to keep it equal at all times. And there's some examples just to kind of talk us through, lead us through the idea of that, I suppose. So just some examples here in terms of these scales. So if these kind of black lines are your scales, we have two things hanging kind of on either side. If the triangle is equal to 3, what is the circle? Well, our scales are balanced. So that means I have 3 here and 3 here. So this side has a total of 6, which means that my circle must also be equal to 6 if they're going to be balanced. The same idea goes in the next part. Again, my triangle here is going to be 2. So on this side again, I have a total of 6. This side also has to have a total of 6, which means the squares must be 3 each. Okay. Same idea goes here. So if the square is 4, what is the circle? Well, this is 4 and this is 4. So I have a total of 8 on this side. This one is 4, and then I don't know what these are. But again, my total has to be 8. The other thing I can kind of do here is because I have a blue square on each side, I can kind of disregard that. I could take one off each side. That's not going to make it unbalanced. So what we have then is that 2 circles must be equal to 4. So 1 circle must be equal to 2. And then following through then for one last one. On one side I have x and 1. On the other side I have 1, 1, 1, 1. So if I add up this side, I get a total of 4. So this side has to have a total of 4, and the only way that can happen is if x is equal to 3. Okay. The key takeaway from this kind of short video is just kind of the idea of what an equation is, so that we should have an equal sign, we should have an answer, and then the idea that when we do something to one side, we have to do maybe the same thing to the other side. That's something we're going to be looking at. The idea is just keeping them balanced. We have to keep the left hand side and the right hand side equal to each other at all times. They have to be equal to each other. They will be equal when they're given, so you just need to make sure that you're not changing them at any point so that they're no longer equal. That's kind of the key thing to kind of make sure that you know with these equations.